Okay, last example, example 17. Before we get there, I would like to say a few things about applications. This type of question you will see in example 17 is a very good example of application question. It is what we sometimes call contextual problems. You also can see that in your CT1 question 9, remember the vectors question, CT1 question 9, you also can see that. They give you a lot of information and then try and make some real life story and then tell you solve a vectors problem. But essentially, it's just a vectors problem. You have to look past the story and then apply your vectors concept. Okay, so it can happen. All the contexts are given to you. To me, you need not be an expert. Sorry, I shouldn't say expert. You need not know anything about them, right? You just need to draw out the vectors concept from them, all right, and then just solve. Yes, okay. Let me give you an idea how to do it. Tell you story. Okay, all these. Some are super important. Some information are not so important. Okay. Is this important? Is it indoor farm, outdoor farm, whatever farm, animal farm, dog farm, whatever farm? It doesn't matter. So to me, this one not important. It's just a structure to be built. Don't get confused. Yes. Then they tell you things like this IJK, or this one I will pay attention. IJK are in this direction. I will pay attention very closely. Yes. And then coordinates of it. Usually when they give me coordinates, I would write down like this. 0, 0, 20. And then coordinates of C are given also. 50, 0, 25. All these are quite useful, I feel. Yeah. All lengths are measured in meters. Now, so given that this is a vector perpendicular to the flat roof, so whether this is a roof or what doesn't matter, I know it's ABGF. All right, ABGF, this plane here, this plane ABGF, and this vector is perpendicular to the flat roof BCHG. BCHG, this corner. That means the two roofs like that. Find the obtuse angle. Interestingly, they ask you to find the obtuse angle between the two roofs. Okay, let's find the obtuse angle between the two roofs. They didn't find acute angle, they want us to find the obtuse angle. Let's solve one thing at a time. Okay? So, to find the angle between the two roofs is as good as finding angle between the two planes, because this is a plane and this is a plane, right? This is a plane, this is another plane, correct? So angle between the two planes is actually just angle between the two normals. And what's so difficult? They already tell you this is the normal, this is the normal. Easy, right? Okay, the first part is not too difficult. So we just cosine inverse the normal. Okay, the unit vectors, the dot product of the unit vectors of the normal. So minus 1, 0, 4, dot 102 divided by square root 17, square root 5. Solve. You get this. You get 40.6. Now the question asks for obtuse angle. So we just give the obtuse angle, 180 minus this. I don't know why they want the obtuse angle. They want the obtuse angle. I think I know why they want the obtuse angle lah. Because you see very carefully, look at the diagram very carefully. This is the obtuse angle that is required. No point finding the acute angle, because this is indeed the roof, correct? This you find the inside obtuse angle, then it makes a bit of sense. Yeah? Okay? Now, next part. Oops, sorry. A humidity sensor. See, again, these are distractor. Whether it's humidity sensor lah, whatever thing lah, it doesn't matter. Oh, you want it installed? Actually, doesn't matter. Correct? Something. A. You just say A is to be installed along the line BGR. This is important. 50 meters away from B, also important. Find the coordinates of the location. Find the coordinates of A. This A something A is to be installed along BG. Where's BG? Oh, here. 50 meters. So you want to install it here. This is your A. Correct? Okay, here. You want to install here. Right? 50 meters. That means this one must be 50. So what do we do? Do we know any information? We only know coordinates of A, coordinates of C, and we know the normal vector of the two planes. So intuitively, I think we just have to take the intersection between the two planes, then we find the line BG. After we find BG, then we decide what to do. Can? Alright? So, do we know the plane ABGF? Yes, we know the normal, which is minus 4, 0, 1. Given, this is given. This is the normal of the plane. This is also given. Do we know one point on the line ABGF? We know A. A is a given point. This is actually OA. Do we know a point on BCHG? Yes, we do. We know what is OC. So definitely we know the equation of this plane. Equation of this plane. You will use GC to solve. Maybe I write down the Cartesian equation for it to be clearer. You get minus x plus 4z equals to 80. You have x plus 2z equals to 100. So you have equation 1, equation 2. You solve. I don't want to go through how you get there. Alright, I don't want to go through how you get there. Eventually, you will get this one. L, line of BG. Line BG has this equation R equals to 40, 0, 30 plus lambda 0, 1, 0. Lambda belonging to real. So we have found the equation of the line BG. Can we know where is the sensor or whatever, like the A lah? So I know the equation of line BG already. Yes. Now here we really have to, you really have to imagine a little bit of 3D. You look very carefully here. Here. This is the I direction. K means upward direction. J means the other horizontal direction. Now, is it obvious to all of us that because this plane is like that, B, the y coordinate of B must be 0? Because you see the y coordinate of A is 0, the y coordinate of C is 0, so therefore the y coordinate of B must be 0. So you want 50 out into G direction. Actually the y coordinate of this point that we want to find, this is the sensor point. The sensor, right? This point is the sensor. The y coordinate of the sensor must be 50 because J is in this direction. Yes? So, therefore the solution is like this. When y is 40, that's 50, sorry, then lambda is 50. So it's why? Because you substitute here. The only way that the y coordinate can be 50 is when lambda equals to 50. So when lambda equals to 50, you just substitute in. Yes, lambda equals 50, you get 40, 50, 30. Done. Yep, all good. Part 3. See, a lot of distractors again. Wow, a metal cable is to be anchored. Okay lah. A cable, something is to be anchored onto the ground outside the farm. Okay, out. Basically, outside the farm, in front. This is more important. This one, in front of OABCD. At a point 25 meters away from O, along OD, and 10 meters in front of OD. Wow, you read like that, I also don't know what he's talking about. But let's look at the diagram together with the words. Maybe I erase a bit of some things first, otherwise the thing looks so confusing. So, you want a cable to be anchored on the ground. See, this one is important. Don't everything also cancel. On the ground. That means you have no Z coordinate. Outside the farm, in front of O, A, B, C, D. Outside the farm. That means here lah, somewhere here lah. Yes, somewhere here. Referring to the diagram. But you want it at a point 25 meters away from O, along OD. That means somewhere here, where the X coordinate is 25. Right? And 10 meters in front of OD. That means the 10 meters here. That means the Y coordinate is minus 10. And the Z coordinate is 0. Now this is what we can infer from there. Not easy, but you've looked very carefully. It is like this. 25 meters from O, terminology. From O, that means along AD. That means the X coordinate is 25. The Y coordinate is minus 10. Why minus 10? Because J is in this direction. Yes? So, it must be minus 10 because it's in opposite direction of J. Yes? Then of course, because it's on the ground, the Z direct coordinate must be 0. So, this is the anchor. Right? This is where the start of the cable. Now, you're going to start from here. Is to be attached to a point on AB to secure the roof. Whatever lah, secure, whatever you want to secure, doesn't matter. You just want to be attached to a point on AB. Enough. So which means this, you want somewhere, you need to attach it somewhere here. Somewhere along AB. Yes? Find the length of the shortest cable needed. Shortest cable. This is important info. It means it can be attached anywhere along AB. It doesn't matter where. It does matters now. Somewhere here along AB. But I just need this length to be shortest. How do you find? So now you have to think. What concept have we learned? Shortest from a point to a line. Shortest from point to line. So therefore you are trying to find the shortest distance from a point to a line. Right? Shortest distance from a point to a line. Having identified this concept, the calculation becomes very simple. Right? The calculation becomes very simple. So, just now we have identified that it's anchored on the point 25, minus 10, and 0. So, you actually just want the shortest distance from P to the line AB. But we must first find what is AB lah. Okay? AB, no. We must first find what is the coordinate of B. Coordinate of B is not difficult. Coordinate of B is 40, 0, 30. Why? Because earlier, maybe I go back here. You have already found this is the line BG. Oh, sorry. This is the line BG. Yes, BG. So when the roof, the B is the point where the X or the Y coordinate is 0. So you substitute Y equals to Y coordinate is 0. Then you get lambda equals 0, so you get 40, 0, 30. In fact, this is actually the coordinates of B. I repeat one more time. B is the point. B is the point where the Y coordinate is 0. Why? Because you see the Y coordinate? You sub Y equals to 0. So B has coordinates 40, 0, 30. So you know coordinates of B, you know coordinates of A. Yes, B here, A here. Then I can easily find what is AB minus, and now I got a direction, AB. So maybe I use a diagram, it's easier. So now I got A, maybe I write down A is 0, 0, 20. B is 40, 0, 30. I want to find the shortest distance from 25 minus 10, 0. Yes? 25 minus 10, 0. I call this point P. I call this point P. Sorry, I'm point P. I missed out. I should label it P. So, basically, I want to find the shortest distance from P to the line AB. You just recall what you need to do. I think we are good. It's just making sense of the story. Correct? So now I find PA. PA is just OA minus OP. Then you get this one. So now I found PA. I am now going to find the shortest distance from P to the line. So I will use what? I'll use cross product. Don't use dot product. Yes, PA cross the direction vector AB. So it is actually modulus PA cross AB over magnitude of AB. Recall, recall this formula. If you don't recall, then I cannot help you. Yes? Yeah. So, which is actually, this is minus 25, 10, 20, cross unit vector of AB 1 over root 17, 4, 0, 1. Of course, you could have used 40, 0, 10, but it's the same. This one, you can use 4, 0, 1. Yes, then you do the done, you do the cross product, blah, 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 and we're done. Then you get 27.4. Let's finish the last part, Last part, state an assumption for the above calculation to be valid. Now this is the one that you think for 1 minute can find something reasonable, write something reasonable. Cannot write something reasonable, write something unreasonable. You write something, some rubbish, you may get 0, but you may somehow get 1. You write nothing at all, you confirm get 0. So write something reasonable. So the reasonable thing is, now we draw stick, draw this object, this structure, as if like there's no thickness. The cable also got no thickness. The building also got no thickness. So actually, we are using lines as if they have no thickness. But actually they do, the buildings actually do have some thickness. But we just simplify the problem. So the assumption for the above to be valid is really the thickness, not they have no thickness, but really in the scale of things, in meters and everything, the thickness of materials used in the building is negligible. Not that it's no thickness, it's just it's negligible in light of the magnitude of the building, the length of the building, 50 meters, etc., etc. Can, like I said, can think of something reasonable, write something reasonable. Cannot, just smoke something. Can? That's that.